Good morning, scholars. I wanted to use some of the tools that we have available on our laptops to show you in greater detail what's going on with these types of volume problems that we saw in class yesterday. So here's the problem that I wrote for our example today. Find the volume of the solid whose base is bounded by y equals 0, by x equals 2.5, and by y equals the square root of 10x. The vertical cross sections of this solid are which are perpendicular to the x-axis are squares. So I've drawn this discretely in Google SketchUp. I used 25 rectangles, each have a width of 0.1. So if you looked at the actual graph of this, it would obviously be continuous and smooth instead of segmented and discrete like we have here. But this is really useful to look at it from a discrete perspective because that's how we take the integral of it anyways. Since the cross sections here are squares, all I have to do to make this a 3D representation, you can see if I orbit around that it's just 2 dimensions. But all I have to do here is look at my table and pull all of these out to an appropriate width. So this first rectangle is height 1, so I'm going to pull it out to a height of 1. And that way, when we look at the sideways here, you can see that's a square, and even I can measure that. You can see in the bottom right corner that says length of 1 inch, and bottom right corner there, the length is 1 inch. So we're going to do that with all the rest of these. The second one, looking at my table, it has a height of 1.4142 approximately, so 1.4142. And then this next one has a height of 1.7321. I'm going to go ahead and continue with these, and you guys can, something's not working. I'm going to figure this out, and then I'll bring you back, and then I'll bring you guys back in. BRBs. And we're back. We've finished our 3D depiction of this object. You can see if we look at this from the top down, it looks exactly like that square root graph. We have that square root of 10x right there, so that's our base. But if we look at it from the side here, we can see that the height, because these are squares, this is actually also a nice representation of y equals the square root of 10x. But you can see here, all of our cross sections are squares. Now, as I said earlier, this is a discrete model. The actual object that we are describing is going to be smooth, completely smooth. But this is also a great representation of how we actually find that volume using integration. But I wanted you guys to see this visual because I think it's really nice. And see you guys in class.